Watching this lesson, you're watching the first lesson on light and optics. In this lesson, we'll be talking about what light is, where light comes from, and in the rest of the unit, we'll be talking about how we use light to see things. So, before we properly start, I'd ask the question, what is light? So ask yourself, what is light? Because it's something we take for granted. So hopefully you pause the video. Light is a type of energy, right? Light is a type of energy. Light can also be called electromagnetic radiation. Or at least it's a form of electromagnetic radiation. So when we look at this picture here, light can exist in many forms, but in this unit we'll be focusing on visible light. So electromagnetic radiation, or light, can come in the form of cosmic rays, X-rays, gamma rays, ultraviolet, infrared, micro, radar, and radio. But this narrow section here, if I were to use, let's just use green here. This narrow section here, all the way across, all the colors that we can see, or that make up other colors, falls into an area called visible light. This is what we can see. And this is a very small area of what is called electromagnetic radiation. So visible light is made of something called a photon. Right? And so if you were to take the smallest thing that light is made out of, you would call it a photon. And they move at 300,000 kilometers a second. Now that's hard to imagine. What is 300,000 kilometers and how much is that in 1 second? Well, this means that if you moved, you could walk at the speed of light. You could circle the globe 7.5 times in 1 second. So this little GIF here shows you how fast light moves. Light is moving that fast constantly. Right? So it's moving around the world 7.5 times in 1 second. And this video will talk about that in more detail. So light moves in straight lines in all directions. So when you have a light bulb, a candle, etc., light is moving out in straight lines in every single direction. We call each line that the light is making a ray, right? So when we look at this candle, light is coming off in this direction, in this direction, in this direction, and so on. Well, we call each line, each of these lines, a ray. A ray. Now, obviously light is going in every single direction, but we only have to draw a few or a bunch of lines to show that light is coming in all directions. You wouldn't have to draw an infinite number of lines to show this accurately. So we just draw like 10 or 12 lines to say, oh well, it's coming in all directions. We call a diagram that shows the rays coming off a source of light a ray diagram. It is a ray diagram because it is a diagram, a picture, that shows rays. Simple as that. So if I asked you, draw a ray diagram from this light bulb, you draw a light bulb and then draw all the rays coming out from it. So ray diagrams are used to predict where shadows will appear. Right? A shadow forms when rays of light are blocked by an object. So in this ray diagram, because we're looking at the rays of light, you can see that this object is blocking these rays. So where the light doesn't hit creates that shadow. So this ray diagram can help us predict where shadows will show up depending on the angle of the light. So here we see that the light is hitting at this angle, and so the shadow will show here. But what if the light was hitting at this angle? Well, then the shadow will be further back. And this is important for buildings. For example, if you were to look at the Bow building, it's actually built shorter than it should have been. And that's because the shadow it cast, if it was as tall as it was supposed to be, would have been casted over the Bow River where animals live, certain protected animals live. And so that resulted in the building being built shorter because they didn't take into account where the shadow would be projected. And so this is an actual application of how ray diagrams, learning how light rays move, learning where shadows are cast, are actually applicable in everyday life. So when light rays travel, they can come into contact with different kinds of materials. Well, if light travels straight through, we say it is transparent. Materials let all light through it, or at least most of the light through it. An example would be glass. Typically, you can see through glass, right? It lets most of the light through. So we say the glass is transparent because it lets light through. Now, if it's a little murky or a little obscured and not all the light is projected through, right? Not all the light is shone through. Well, then we say that it is translucent, sort of like a middle transparent. It only lets some of the light through. For example, clear plastic cups, right? They're a little hazy. They don't let the light through completely. And so we'd say they are translucent. And when no light is allowed to pass through, so light will hit and then stop, we refer to materials that don't let any light through as opaque. So for example, a carpet, your body, a wall. These are things that block all the light from coming through, and so we say that they are opaque. These are key terms you need to know, hence why they're bolded. So I recommend you know what transparent means, translucent means, and opaque. So far, this has basically been a review of grade 4, but this is good to know as we move forward in this unit. So, we know that light travels in straight lines. We know light travels incredibly fast, the fastest thing in the universe. Where does light come from? Or at the very least, where does our light come from? Some of you may have already guessed this, but what sources of light are there? Well, some of you may have just said the sun. Some of you may have said man-made. But some of you may have even said through biology. Now this one's fun, I like that one. Right? So light can come from the sun, light can be man-made, and light can come from natural biology. So we're going to start with the easy one, the sun. The sun is the major light source of Earth. Right? So if I asked you on a test or something, where does the majority of light on Earth come from? You would say, well, the sun, because 99% of all life on Earth requires sunlight, right? So the majority of the light that hits the Earth is from the sun. Now I say 99% of all life because not all life needs light. There are very few rare exceptions where certain animals don't require light. But the sun is the major light source for Earth. Incandescent light sources, or man-made light sources, right? So these fall under man-made. Incandescent, you may see fewer and fewer of these as time goes on, but light sources of this type use energy. They use energy to heat metal until it emits light, right? It heats metal until it creates light. So in an incandescent bulb, you would have electricity flow through here, go through there, and go down. Now, here, I'm going to use a different color. I'm going to use red. Here, this metal gets heated up as electricity passes through it. This metal is called a filament. And when enough energy is applied to the filament, it starts to glow. And you've probably seen this on a stove as well. When you have a hot stove, it turns sort of a bright red orange. And that's because the metal is now releasing extra energy as light. And that's how incandescent bulbs work. The metal vibrates or gets heated up by the movement of electricity through it. Another man-made type of light is fluorescent light. Fluorescent bulbs use mercury in their bulbs. When electricity passes through the mercury, the atoms become excited. And what that means is they start to move around, and later on you'll learn that electrons move up. Well, eventually everything that goes up must come down. So the electrons need to come down. And when they do, they release UV light. Well, there's a thin layer along the inside of a fluorescent bulb. And what that thin layer does is it converts UV light into visible light. Which is why they're so bright and also why you shouldn't break fluorescent bulbs because they're filled with mercury, and mercury is toxic. So fluorescent bulbs use mercury to create UV light. The layer inside the bulb allows it to convert UV light into visible light. And then there's something called chemiluminescence. Basically, big word broken down into chemical. Luminescence means to light, or just light. Chemical light. This is when a chemical reaction produces light. And a common example, which you probably all have seen, is the glow stick. Right? If you've ever used a glow stick, they always recommend, or they always say that you need to snap or hear a popping sound when you crack the glow stick, right? Well, what happens is that there's two chemicals, and I don't know their names, in the glow stick. One is encased in glass, and the other one's outside the glass, so they're separate. And when you crack or bend the glow stick, you break the glass, causing one liquid to spill into the other liquid. That chemical reaction produces light. Any chemical reaction that produces light is said to be chemiluminescent. And the fun one, bioluminescence. So this is not a man-made source of light. This is where biology can start creating light. Bio means life, and luminescence again means light. So bioluminescence means life light. And this is made by living things. So there's types of mushrooms that glow and produce this greenish glow, and it produces a protein called luciferin, which makes it glow in the dark. There's also plankton in certain areas. If you were to go to Ireland or India, there's certain areas where these little plant creatures, plankton basically, will start to glow when they're disturbed. So when you shake the water or when the waves roll by, they start to glow. And so they create this really cool blue glow. And the classic example is the firefly. Right? Fireflies will produce this light to attract mates or to signal each other to stay away, etc. And so these are all examples of how light exists in our life. 99% of it, or the vast majority of it, from the sun. We can also use incandescent bulbs, which are seeing less and less now. We also have fluorescent bulbs and the occasional chemiluminescent. And if you're lucky, you get to see some bioluminescence as well. Light can be described using light rays because light travels in straight lines, and they're useful for showing shadows. The focus of this unit will be focusing on visible light, right? And that only includes a very small segment of what light actually is. Right? Because if you start moving up into other areas, it's still light, but it's called something else. So hopefully you found this useful, and I'll see you next lesson.